yesterday with completing the square. First thing is, again, we're going to complete the square. And what we mean by that is taking that constant term, kicking it to the other side, and creating what we say is that perfect square trinomial. So we can then factor it. And the way that we did that yesterday was seeing that there was a pattern here. I gave you a binomial squared. And you guys multiplied that out. Cool. We saw that there was this trinomial that you created. And we had you go backwards. And right here, what did you guys create for this new constant term? This new c is what? 7. And 7 squared gives me what? 49. And the way we're getting that 49, as we saw, you can put that in there. But remember, we're doing 1/2 times negative 14, which is n squared. And it should be always a positive, as you said, 49. And whatever you do to one side, right, you have to do to the other. You got to keep the equations balanced, right? So plus 49. Okay, and right there, that's where you should always create something that is factorable into the same two quantities. So it should not be like a super difficult thing to factor. R squared minus 14r plus 49. If you did the practice last night, you should definitely see that there's a quick pattern there every single time. That 49, the factors of 49 should be pretty quick. It should be those 7s right there for you. And when you factor that, one more time, it should always be the same two quantities. If you're saying r minus 7, r plus 5, you're doing something wrong. It should always be the same two quantities. Right-hand side, add it up, whatever that is. In this case, it's 129, right? Whenever you get those same two quantities, what do we do with the same two quantities? Rewrite it as, right, the quantity squared. All right? Now, right there we said from yesterday, okay, we were kind of stuck. But I said, we ain't stuck, we just have to talk about it. Okay, because now this brings in our square roots from the beginning of the school year. We said from our beginning of the school year with the square roots, we hadn't done that yet. We did something like from the beginning of the school year, solving these by square roots. Okay, the quantity squared now is what we're dealing with. How do you get rid of a square? We take the square root of both sides. That's what we have. And when we take the square root of that, that gets rid of the squared, unlocks that r minus 7. And on the right-hand side, you all know how to deal with the square root of 129. Does 129 go anywhere? Say 129 seems pretty odd there. It doesn't go anywhere. But how many solutions do we typically get? 2. So don't forget my plus or minus. Okay. One more thing. Gotta get r, right? So how do we get rid of that r? Sorry, how do we r by itself? Plus 7. So we say 7 plus or minus square root of 129. Okay. And as I mentioned to you guys yesterday, these solutions should look pretty similar to what we did last week with the quadratic formula, because completing the square is done with us from the get-go to help us derive that quadratic formula. We're not going to do it. It's not worth our time right now. You might talk about an extra in algebra 2, and really it's just not worth our time. Okay, but this is again what we call an irrational solution. You still get that square root in there, which tells me again, this we could have tried to factor it, but this would never be factorable. Factors of 80 that give me a 14 is never going to happen. So when it can't factor, you get 2 backups. Quadratic formula, complete the square. We're going to focus on the complete the square method today. All right, let's go with another one here. Let's go do drop down. Let's do number 3. Okay, let's go do number 3. 3 looks ugly because it's not in standard form. Go put it in standard form. Let's go tackle it. Okay. As with anything that we do with quadratics, if it's not in standard form, let's start cleaning it up and rearranging it and seeing what the heck is there. Okay. Let's see what's going to be our most efficient way to do that. Now we are going to focus on complete the square right here, but put it in standard form. As you start moving things around, 3p squared gives me what? 1p squared, right? Minus a 4p, right? And hopefully you realize I'm going to have to add over a 53. Yes, no, maybe. Okay. Leave myself some room and tackle it. Go ahead. Okay. Look at the process we did right above. Do it on your own. Okay. Follow the steps that we did above, and give you a minute. Try that on your own. Okay. We have to turn that back on. Take number 5. Create me a quadratic equation that has those two solutions. I want it in, first off, factored form. What's that going to look like if I have something that has those two solutions that is in factored form? So if I have an x equals -3 and an x equals 3, what's that going to look like? In factored form. What does factored form look like? Something something equals what? 0. That's factored form. Okay, that's what we've been focusing in on most of the second semester. So if we got x equals -3, what did it have to look like the step beforehand? X what? Oops. It had to be x plus 3, right? Equals 0. And what did the other one have to be? That's it. In order to get a -3, it had to be a x plus 3. In order to get an x equals 3, it had to be a what? X minus 3. So therefore, what did my factored form, keep going backwards in your head, what did the x plus 3 equals 0 had to be? Times what? Equals. That's the factored form, guys. That's our sweet spot. That's where we always want to be. And then we use our zero product property to get our two solutions. Now go one more step. Put me that in standard form. You're now in factored form. Great. What does that look like in standard form? So what standard form look like? Well, we've been doing standard form all second semester. You want to be in that standard form. That's everything needs to be in. Ax squared plus bx plus c. You got it in factored. Put it into standard now. So how do you put that in standard? Got to distribute, right? Yep. Go through and distribute that thing through. You should be able to distribute that thing in your sleep. All right? With your eyes closed. And x squared, and what's going to happen to those linear terms? Going to cancel and be left with x squared minus equals 0. So if you go through and do your distribution like we've been doing, linear terms cancel, and there you go. That's all we need. Okay, those are good SAT style questions too. Kind of going backwards on that. Now, a lot of times those are more multiple choice questions. Okay, but I pulled off multiple choice. Same thing in the last one. If I give you an x is 0 and x equals 3/5, what did the factored form have to be? In factored form, what's that? You had to have a GCF in that, right? If I had a 0, that means a GCF is happening. So a 3/5 means undo that 3/5. If I have to undo if I have to undo division, that means I have to have what? Multiplication, right? And now I'm at 5x equals 3. And how do I get to that to 0? Minus it, I heard. Okay. And the nice thing is you can always check it. You can always check it because what should it go back to? It should go back to 3/5. Does that go back to 3/5? Yeah. Add 3, divide by 5. If it doesn't go back to 3/5, well, go do it again. So that's one of those, and what's the other one? X equals, well, 0. There's nothing else I can do with that. So as we've done with as Jillian suggested, this is going to be one where we had a GCF happening there. We talked about one thing just yesterday. We did a warm up with that. Okay, I reminded you about if you get one that has a solution of 0, the only way that happens is it's a GCF. That's a GCF. That had to happen. Okay. Now, what's it look like in standard form? Distribute that on through. When you distribute that on through, what do we got? Again, the reason why it was a GCF, what are you missing? You're missing that constant, that C term. C is 0. So those are quick things where I can tell you, if you're feeling pretty good about that, cool, algebra 2 honors. If you're feeling hesitant about that, algebra 2 is going to keep working on those skills with you. Okay. Now let's go to the next page, and I get a hot jumbled mess of a bunch of quadratics. Okay. Now on that hot jumbled mess, a bunch of quadratics, this is again SAT. SAT is not going to necessarily say, hey, use this method, use that method, use this method. It's just going to say, hey, go solve it. Okay? What's the best method for the job? All right. So I got a couple of them on here. Let's go do number 8. All right. We're going to jump around here. Let's go do number 8. Well, what's the first thing you want to do here to tackle that out? I got to put it at 0. Let's go put it at 0 and let's go figure that out. R squared minus 12r, and what's it going to be? What's that? I think 19, isn't it? 19, okay. Small things, minus 19. Now, remember, in your tool bag, you got 4 methods. You got 4 tools. Can we do square roots here? If I can do square roots, I'm going after square roots. Can I do square roots on this one? No. I've got all 3 terms. Square roots does not work with that. Factoring. Factoring is a possibility. Now the question is on this one, can I factor? If I can factor it, I'm going to try that because A is 1. If A is 1, that's super quick to factor. 19. Factors of 19 that give you a 12. Does that work? That's a quick thought. That's not going to happen. Factoring's out of the question now. So now you have 2 backups. Quadratic formula or complete the square. Flip a coin, it's your call. What do you want to do? Pick one. Somebody step up. Please flip the square. Thank you. I don't care. It doesn't matter. Flip the square quadratic formula, it's totally your call. So that's the thing. You got to commit to something. On the SAT, you're going to then make your own call. You're going to have to commit to complete the square quadratic formula. I don't care. I'm not going to be there for you. You're going to have to make your own call then. Okay? So, complete the square. Let's go at it then. Especially if that's right now our most recent thing. Go at it. Okay? What did you create for that constant then? The 36, I believe. 1/2 times negative 12, which is negative 6 squared, which is 36 to the left, and 36 to the right. And there's that perfect square trinomial. That should result in same 2 quantities. Same 2 quantities of r minus 6. R minus 6. 19 plus 36. What is it? 55. Okie doke. There we go. And last but not least, we got to do what? Yep. Square root that thing. How many solutions typically? And can we do anything with 55? 55 go anywhere? 11 and 5, does it go anywhere? No. So 55 is good, isn't it? Square root of 55. So 6 plus or minus square root of 55. Okay? So I'm going to look for multiple choice answers that would have that on there. Okay? All right. Let's go do another one. Let's go do number 9. Okay, number 9. What's your first move, guys? Do the standard form. 9x squared plus 18x, and then what? Minus 16. All right, let's do this. Go through your 4 tools. So reach into my tool bag. Am I going to use square roots? Yeah, definitely not. Square roots can't happen. Then I have my other 3. Factoring, quadratic formula, or complete the square. Now, here's the thing about this one. I get a 9 out front. Do I have a GCF I can pull out from here to help me reduce the size of this? 9, 18, and 16. Is there a GCF up there? Oh, 16? Does 16 work on that? No, so no GCF. I was going to try to see if the GCF would reduce my size. I'm always looking for that, but unfortunately, a 3 ain't happening. So I can't reduce my size. Therefore, complete the square ain't happening right now. We could do complete the square on this, but we're not there yet. We got to do some more work for ourselves. We're not going to talk about complete the square yet on that. A has to be 1. I'm not going to have the time to get to completing the square with this. It's doable, but we're going to make ourselves much tougher work to do that. We're going to have some fractions. I'm just not there with you guys yet. Complete the square, you're just not ready for that yet. Factor or complete our quadratic formula then. What do you want to do? I'm going to use quadratic formula myself, right? Because quadratic formula, it's quick, it's simple, it's just a formula, plug and chug. Factoring works, you can definitely do it, but I like to use the formula because I don't have to think about it. I just got to do it. Factoring, I got to think. Let's go use the formula. X equals negative b plus or minus b squared. What's b? Minus 4 times a times c all over what? 2 times a. The only thing you got to think about is, have you done enough practice here? I gave you enough practice last week. Do you remember your formula? That's on you. SAT will never give that to you, but it's a very handy formula to know. Okay, let's go focus on underneath that square root. Calculator says 18 squared minus 4 times what's a? A is 9, and what's c? Negative 16. Check me, check you. 900. So I get 900. Yes, no. Check my arithmetic. So I get 900. 18 squared minus 4 times 9 times negative 16, guys. You gotta be checking myself as well. It's easy to screw up something. Don't just sit there and stare. So, I finally heard somebody say 900. This isn't for my health. Screw to 900. 900 is what? Screw 900. It is perfect. Right. 900 is perfect. That's a 30. And what that tells me now is you could have actually factored this. This one was factorable from the get-go because it is no longer irrational. Now you have to commit. You can't stop here. You have to commit to finishing this up. You have to separate this out to your 2 rational solutions. Negative 18 plus, negative 18 minus. So go and commit now to your last 2 solutions. Negative 18 plus 30. And the other one is not that. Negative 18 minus 30. So what do you get then? Okay. Calculator's your buddy. Divided by what? 18. First answer is ugly, so we change it to a fraction. Somebody got 2/3. And on the second one, negative 18 minus 30 divided by what? 18 again. Again, ugly. Fraction says somebody get negative 8/3. Those are my 2 solutions. Okay. So what that tells me is, again, if it's factorable, it might have been quicker. I don't know. But quadratic formula, it's just a plug and chug. Okay, that's my go-to. Extra algebra 2, probably your go-to in that case. Okay. All right, let's do a couple more here. Let's go do number 12. Number 12 there. What's the first thing we notice in number 12? It's a binomial. What are we missing so that we can do it? We're missing the b. We're missing the b, the linear term. We got the constant. We're missing the linear term. Right, we're missing the b. And when I'm missing that linear term, the b, what tool are we reaching for? Square roots. That's the best way to do that one. That's what we want you to be able to realize. Not just be able to solve it, but be efficient about it. Solve by square roots. But I can't square root it yet. What do I got to do? Nope. I just got to divide by -8. I could put it in standard form. I could. But let's just be smart about this and divide by -8 and then square root that thing. Okay, it's almost there. Just square root it. -80 divided by -8 says 10. And now I can square root that thing. The square root of 10 is, it's nothing, is it? The square root of 10 isn't it? Plus or minus. That's a quick solve. Okay. Again, that one's all because linear term's gone. No linear term, I'm going to square roots all there. But you got to have that a to be 1 before you square root that. Okay. So we had a hodgepodge of problems back here. Let's take a look at number 11. Let's walk it backwards to number 11. What are we doing on number 11 there? What are we choosing for number 11 in our toolbox? Factoring, square roots, leave the square. What are we doing? Hopefully we're choosing none of the above. What is it already equal? It's already in what form? It's not in standard. It's already in factor form. This one was gifted to you, so don't throw away this gift. Okay? Don't go and distribute this on through. You're going to make your life so much more difficult than it needs to be. It's already set for you. Give me my solutions. Use your zero product property. You need to realize the structure that's there. It's equals 0. Sweet. 5n minus 3 equals 0. There's your first solution. 7n minus 6 equals 0. Sweet. There's my second solution. Do I care about that 4 out front? There's a variable there? No, I don't care about that 4. That 4 is just a random GCF out front. Don't care about it. There's no variable with it. Doesn't mean anything. What's my first solution then? N is 3/5. What's your second solution? N is 6/7. Okay? Just what we did on the other page. At the very bottom of those two, where we were given the solutions and we wrote it in factor form. We wrote it in standard form. Factor form is where you want to be. And if you notice that we were in factor form equals 0, we're great, we're golden. Don't throw that away. It was given to you. Okay? All right, let's finish this off here. 13. What do we have on 13 then? Are we equal to 0? No, we're not in factor form this time, are we? So how are we going to solve this one out? We're going to be almost completing the square. You're right on the track there. Doesn't look very similar to the second half of completing the square. Right. So as we just said here, and it's at the end of the second half complete the square. This is bringing in our updated version of square roots. Okay? We're right here. P minus 2 squared equals 57. It's solving by square roots now. It's the second half of completing the square. If I have that quantity squared now, we can solve this by square roots. It's our updated version of solve by square roots. That's it. We're done. X plus 3 equals what? Plus or minus? Somebody just said it. 2 root 2. Okay? So, as we just keep working along, we've thrown out some new things here and there. Okay, we just threw out that yesterday. We're going to keep throwing out some new things with that. It's just an updated version of square roots now. If you had that squared right there, cool, we did it. Subtract that 3. Plus or minus what? 2 root 2. Okay? All right. Okay, last one and we'll call it a day. Find the y-intercept of this function. Now we did graphing last week. I had put some graphing of quadratics on your review from last week throughout there. And we had reminded you guys about how we find y-intercepts. Y-intercepts occur when what? If I graph something, if I graph a linear, the y-intercept occurs when x is 0. Who cares if it's a linear, or who cares if I change that to a quadratic? My y-intercept is right there, also at 3, 0, 3, still happening. So the y-intercept occurs when x is 0. So when they ask you again to find y-intercepts, just replace x as 0. It's the function work that we've looked at. It's that input-output. The input is 0. When the input is 0, when the x is 0, what is the output? That's it. When the input's 0, what's the output? Don't think, just do. Get your calculator, clean it up for you. Okay? Go to your calculator. Can you type it into your calculator correctly? Okay? Do parentheses matter? I think so. We talked about enough of that. So if the input's 0, what is your output? Somebody get negative 14? If you're not getting negative 14, check me. I saw some heads nod. It means that you didn't type it in correctly. Okay? So on that quadratic, all right, the y-intercept is 0, negative 14. If you were to graph this out, this dude right here, we are unfortunately run out of time. We're not going to have enough time to talk about that. Algebra 2, you guys will. It's going to tie into what we were talking about, completing the square. Okay? But that right there, this form, ties us into complete the square. We can take our ax squared plus bx, or standard form. Complete the square takes me into right there what we say is vertex form. Complete the square takes me there. So that's how we're going to talk about that next week, in 2 weeks' time, of how we can do that in our geometry section. It's going to tie into that a little bit. Okay? But complete the square does that for us. And I will talk a little bit more about that. Not fully, but I'm going to set you up there. All right. Here comes some hard copies.